Alright, so in this section 6.5 we're going to take a look at simplifying and working with complex fractions. Of course, what we need to do first is define, well, what exactly is a complex fraction, because many of us will feel that a fraction is already pretty complicated as it is and they're complex. So that argument could be made as well, but what makes a fraction complex? And really what makes it complex is if the numerator itself is a fraction, oops, can't spell fraction there, if the denominator itself is a fraction, or maybe they both are fractions. So we have basically fractions within fractions. So case in point, let's say here's my fraction bar, I'll make it really big, and then I have the fraction 1/2 plus 3/4 up in the numerator. So in this case, the numerator, right, is essentially a fraction itself. It's not just a fraction, it's a sum of fractions, so it's quite complex and complicated. And then the denominator could be the same thing. You know, perhaps the denominator is, let's say, 5/6, and then let's say we're subtracting, or I'll add 1/3. Okay, so what we have here, right, is basically a very complex looking fraction. I have one big fraction bar, right, whose numerator is made up of a sum of fractions, and whose denominator is made up of a sum of fractions. So very, very complex. So how do we simplify this, right? How do I just make this look like a normal fraction where I just have a number over a number, right? This is difficult enough. So how do I make this turn to that? So how do we simplify? Well, it turns out that there's two different ways we can do that. One is to treat it as three problems in one, and the other is to use a very famous balancing act by multiplying by 1, and I'll demonstrate them both. In the three problems in one variety, what we're trying to do here is we're actually trying to build up to the division. Keep in mind, a fraction bar like this means we're dividing. So we're taking this sum, whatever it is, and we're dividing it by whatever this sum is down here. So we're going to simplify the top, that's one problem. We're going to simplify the bottom, that's a second problem, so that we can perform the third problem, which is dividing fractions altogether. So three problems in one, building up to the division. So here's how this would look if we decided to use this simplification practice for this. So the first problem is to basically perform the addition upstairs, right? Well, the common denominator is 4, right? So this one will need a 2/2. We have 2/4 plus 3/4. This combines up to give us 5/4. So this top fraction basically simplifies to the fraction 5/4. But the second problem is to perform the addition that's happening in the denominator. Well, again, to perform this one, we need a common denominator. It's 6. This will also need 2/2. So we get 5/6 plus 2/6, and we end up with 7/6. So the third problem, here's what this looks like. So we started off with the complex fraction 1/2 plus 3/4, 5/6 plus 1/3. And from our previous work, we now know that the top fraction is 5/4 and the bottom fraction is 7/6. So we all have a division to do. So let me rewrite this. This is the fraction 5/4 divided by the fraction 7/6. So we built up, right? The first, second, third problem, we basically built up to a division. So how do we divide fractions? We multiply by a reciprocal, right? I always kind of like to figuratively do the multiplication because it's a little easier to see the like terms here. 4, right? 2 goes into there twice, goes into there 3 times. So it looks like we're left with 15/14. So this very complex fraction, when all said and done, is 15/14. And I don't know about you, I would rather look at 15/14 despite, rather than that complex fraction looking over there. So that's one way to do this problem. The next way is to use a very famous balancing act of mathematics, and you actually saw me use it a couple times up here. This whole idea by multiplying by 1. What that does, as long as we do the same thing to the top and the bottom, is it creates another fraction, in this case 2/6, that looks different and feels different, but it's equivalent to the fraction that we left here. We've essentially multiplied 1/3 by 1. And we know that if we multiply something by 1, we get it back. but I chose, one's a kind of a weird thing because it's 2 over 2, 3 over 3, 4 over 4, 5 over 5, x over x. These are all 1, right? But I happen to choose to use 2 over 2 in both cases because that's what was needed to build an equivalent fraction that had a common denominator that I was trying to add. So we're going to actually use the same balancing act, but we're going to actually be a little more creative with it in this case, because what I'm going to do is use it for the whole fraction. So I'm going to take my complex fraction 1/2 plus 3/4 and 5/6 plus 1/3. And rather than finding individual LCDs, in this case 2, I'm actually going to think about the LCD for the whole problem. So what's a common denominator for 2, 4, 6, and 3? Well, they all go into 12, right? 2 goes into 12, 4 goes into 12, 6 goes into 12, and 3 goes to 12. So what I'm going to do is take and multiply, right? There's my form of 1. I'm going to multiply the top and the bottom by 12. Right? And it looks kind of weird, but you got to remember I'm just building an equivalent fraction. So whatever this ends up being equal to will be equivalent to the fraction that I had because I technically just multiplied by 1. All right? But let's see how this works. So remember, we're going to multiply that to that. So we really, let me go ahead and rewrite it one more time. And I think eventually I'm going to write that as 12 over 1 and 5/6 plus 1/3. So we're multiplying the top and the bottom by 12. Well, if we distribute here, 12 divided by 2 will leave us with 6. 4 divided, or if you want to think it this way, 36 divided by 4 is going to be 9. Don't forget the plus sign. All right, so 3 times 12 is 36, divided by 4 gives us 9. Same thing on the bottom. 12 times 5 is 60, divided by 60 leaves us, divided by 6 leaves us with 60 divided by 6 leaves us with 10. All right, and then 12 over 3 would leave us with 4. And so now that I've cleared the fractions basically by using this balancing act, I'm just left with some simple addition. The top we know to be 15, the bottom we know to be 14, and lo and behold, that's the same answer that we got there. So I prefer this balancing trick because once I found that LCD, something that goes into everybody, it helps me basically clear the fractions from the numerator and the denominator, and all I'm left with is a simple addition or subtraction or whatever we have left, and we can go from there. So hopefully you're convinced. There's 2 ways to do the problem. If you're very proficient at adding and subtracting fractions and working with them, perhaps you're a 3 problems in 1 guy, but if you like clearing them, take full advantage of this balancing act that if I multiply the top and the bottom by the same thing, in this case our LCD, doing the multiplication essentially clears all the fractions out. I no longer have a complex fraction. I simply have an addition or subtraction to do, and then simplification, and then we're done. So this is what you're going to see me using quite a bit in the videos coming soon. So get used to it. I hope you like it. If not, feel free to do that. Just show your work. All right? So see you in some videos coming soon.